Hey folks, Michele here. This is a new video about composing with Bach and Cage, and in this video I'm going to show how to distort a score using a BFG noise generator, an object that is present in Jitter and that generates a lot of nice texture, a lot of nice noises, and we're gonna use that information to distort a score that I downloaded, a MIDI file. This is the original score. It's a chorale by Bach, Aus Tiefer. After I pass it through this noise generator, and you can see how there are some parts that are noiseless and some parts where the noise kicks in. I have something Okay, let's get into it. The first thing I want to do is load a file on the Bach roll. So I created a Bach roll object and I loaded a MIDI file. And then I like to get rid of the markers in case there are any. And to do that, you can do select markers and then send a delete selection, and that will get rid of all the markers. And then we want to create a new Bach roll. So I'll just copy this one for now, but we are going to iterate through the different lists and add distortion based on the jitter object jit.bfg. The jit.bfg object is like a jitter matrix. You don't need to know exactly how this works. You can just copy and paste it from the help file, or you can follow along here. I have 3 planes, meaning it's going to be 3 values per cell, just like a color. And then a data type, which is 32 for more precision. And the dimensions are going to be 127 on the Y dimension, meaning there are going to be 127 rows. And why is that? Because I want each MIDI note to match a specific row. Then have like a large X dimension. Why a large X dimension? Because I'm going to match the length of the score to the length of the matrix, of the length of this noise table, and to do and to get precisions into reading throughout the length of the score. I want to have a fairly big X dimension, so that I don't get multiple rhythmic events clamped into a single cell. This just needs to be generated once I decide, once in a while, and so I can just keep it as large as I want. And of course, you can do fancier mapping with microtonal tunings. And in that case, you would need a larger Y dimension as well. The attribute that I need for this object is the basis, which is the kind of noise, and we can do noise checker, for instance, which is one of the noises that we can get from this, but you don't need to know the kinds of noises that are inside. You just need to grab a attribute explorer and go to the basis, and then now I have it selected to noise checker, and you have to look through the noise values, and there are many. So let's see what this outputs. So I can attach a P window just to inspect what the output of this will be. and I can make it as large as I want and see what I get. So this is one kind of noise, and let's see another one. Fractal mono doesn't give me much. Voronoi gives me this nice thing. But I do want to have immediately like a scale attribute, and the scale, let's scale it uniformly across all dimensions. And once I scale, I need to retrigger this. Now I have, you can see a much a grainier texture. This is something in between. So you can see here how I get something interesting. It's a good rule when you deal with noise to normalize it so that my vectors are always going to be between the vector magnitudes are going to be from are going to be 1, always 1. I want to map this onto this core based on the pitch position of the event and based on the rhythmic position. So the pitch position is going to be mapped onto the Y dimension, and the rhythmic position, meaning where it appears on the score, is going to be mapped to the X dimension. So now I can check what my output of the conversion from Jitter to Bach is, and if my nested list matches the dimension 1127. So the first length will be the number of rows that I have, and that gives me 127. If I pick one of the rows and check how many cells in that row there are, I will see that it's 1000. So the conversion happened correctly. This patch will be available for my Patreons, so you can either follow along here or download it directly from Patreon. And then now I can store this into a Bach reg and select the note based on the placement of the note on the score and its pitch. Do Bach reg. So once I create an address, I can send the address to the nth object, the Bach nth object, and then a bang to the Bach reg, which will feed the nth the list from which the item needs to be picked. I need to create a Bach iter, and I want to iterate 4 different lists, and I want to have 4 different lists. I will have the onsets and the address of the onsets, then sense, address, etc., etc. To get the address on the X dimension of the matrix, what it's relevant for me is the onsets. So the onset will be collected to build the new score, but I need first to create an address from which to read the matrix. So I'll go ahead and create a TLL. So remember, when we deal with Bach, we always need to use the L for max objects as an identifier, as a data type, because it will not recognize Bach syntax. So, and then I can go ahead and just create a bunch of Bach plus, because I'm going to create some noise and I'm going to add that noise to each element. So something like that. I create noise for sense, noise for duration, and noise for velocity. Okay. So, and finally, I want to collect add the noise, collect it, and then when I'm done, I'm going to fit it to my new distorted score. If I trigger this, it will just rebuild the score. It's not going to change anything, but now I have the ability of changing each of the note based on some value. To get the correct placement of the note in the score, I need to collect the length of the score, and with the get length command, I can then divide the onset by the total length, and so I can get a normalized value that then I can multiply by the x dimension of the matrix and get the correct cell in on the x. While for the y dimension is even easier because I can just get the MIDI note and then address that to the specific row in the matrix. Bach keys. Bach keys is just like a root object, and if I give it the attribute keep1, will become a root pass object, meaning it will keep the keyword when it outputs. But we don't need that for now. We actually need to get the length. Actually, let's first get the note message. The note message will be output whenever I play back the score, and then I can use that information to play back the score. And then like with some synthesizer or whatever. And then I want the length keyword because I want to know how long the score is. And for now, that's what I'm most interested in. So I connect the play out outlet to the Bach keys, and then I need a get length message, and Max is smart enough to give you autocomplete suggestions whenever I'm close to some object. Now I'm close to the Bach score, so I have the get length is the second one on the list. And let's connect this to Bach print. My total value is 45 seconds. If I do a Bach pick, the onset is 3-1 in the note. So in the output of the note, third list item, and it's the first one of that list. If I divide this by divide by the length, which I get from here, so I need to press the get length again, and then I can press play, and now I have a normalized value. So now it will be 1 at the end, and before that it will be a value from 0 to 1. So, but the note I need is not the one coming out of the playback. The value that I need to change is the one that comes out of the Bach eater object. So this is my onset value, and my pitch value will be my second outlet. I can just do a Bach expert and divide that by 100. Why 100? It's a MIDI cent, so it's a MIDI value times 100. So to get the actual MIDI note, I need to divide it by 100. Why is it a MIDI cent and not just a MIDI value? I explained this in previous videos, so just feel free to go ahead and watch the other 8 videos if you haven't already. So this is my second this is my Y dimension data that I need to use to retrieve the cell that I need. Okay, so what I need to do here is, since this is going to be my trigger to output the noise cell, then I want to have a Bach reg for each one of these values. So I can retrieve the cell that I want, get the value, the noise value, and finally add that noise value to the stored score value information, and that's going to be my time information. So where on the so I need to invert the address. Either I could transpose either the matrix or transpose the Bach reg, which I can easily do, or I could just invert the address to get, because I need the row information first, and then from that row I need to pick the right cell on the X dimension, which will be the second item. And since this will come out after, I need to give it a attribute at triggers 2. So a bit tricky. The at triggers attribute in Max is also used, but usually it's indexed from 0, and in Bach it's indexed from 1. So this is actually inlet 2. If in doubt, you can check what the color of the inlet is. The red color means that it's a hot inlet. I had a couple of mistakes. The round object, the round it needs to be all of it in parentheses. I had the multiplier outside, and so that was giving me a problem. And then I need to, every time I reinstantiate this object, I need to resend this value in. So that's always to be remembered. And now I can get the address from this, and the addresses will be correctly formatted. You can see this second one will be the X dimension, and it increases continuously. This is a new voice, that's why you get a new 0 value, because the Bach iterates through each voice at the time. And so we get very close to 1000, and these are my pitch values, my MIDI notes. So from that, I can first of all generate something a little more interesting here, like that, this noise, and then let's see what comes out of the end, because now I have stored my matrix into the reg object, and I have these values. And in the case of checker, you can see how they are usually just kind of like either the kind of binary, either 0 or or 1. But if I change the noise, the basis, and let's get a nice Voronoi, for instance, like that, even less. Let's do something a little smoother. And now I get a little more nuanced values. So each of these values will be can be used to shift the notes, their onsets, or their pitch, or duration, or whatever. So what I do here is I can first of all do a Bach pick. 1, 2, 3. Bach pick indexes from 1, so the first element is 1, it's not 0. And then I can, since these values are going to be from 0 to 1, I can divide it by 0.5, multiply by 0.5 and subtract 0.5 to oscillations that are bipolar, both positive and negative. And then I can add them to my pitch, my velocity, and so on and so forth. Here I've added a oscillations in the noise. So in the in this patch, in the jit.gen patch, I've added a sine function, so I can kind of fade in and out of the noise. And I also added a power function, an exponential function, to make the fading in and out steeper or looser, like so, for instance. Now it will be distorted except for small points. And then I can decide how many MIDI cents I want to add. So this is in MIDI cents. So it's 100 for a semitone. So here I would have more than a semitone. And this is how many milliseconds in the shift. And you could hear there when he got to the black part, he went back to less distorted. Please let me know if you have questions, if you have topics that you would like me to go over. And until the next time, take care.